Today we are going to look at probability. Why do we need to study probability? Probability we are going to study because probability is a branch of mathematics which deals with the chances of something happening. Chances of something happening. So why are we studying probability in statistics and for managers? Because life and business is unpredictable. There are to be able to decide the best course of action, managers need to understand what decisions to take and what are the effects of those decisions. Let us say there is a company, an electronics company XYZ, and let us say they have two research teams, research team A and research team B. Now let us say team A says we need to introduce a phone with a bigger screen, and team B says we need to introduce a new music system. Now the company has a limited resources of time, money, employees. These are limited, so the company can either go with TA, the phone, or with the music system. Now before they do that, they should be, if they can come up with some chances of what are the chance of this being a success, what are the chance of this being a success. If somebody can come up with the numbers, then they will be able to make a better decision. Even we make decisions similarly. We understand the probabilities, chances. We may not know that we are using probability, but we are using it unknowingly, or in some cases some people may be doing it knowingly. Like for example, how many people choose sports as a career versus education? Excuse me. So there are very few people who choose sports and very large number of people who choose education. Why is that? Because the success rate in sports is very less, whereas in education there is very high. For example, there are 11 team members in Team India for a cricket match, for a cricket team. So what are the chances of somebody making it in the top 11 versus suppose somebody wants to be a doctor, an engineer, a lawyer, or a chartered accountant, or an MBA finance, or MBA marketing. See, the number of people that can get employment in these areas versus the number of people that can make a living in sports, the chances are very low in sports, and when compared to sports, the education is very high. That is the reason why most of us are choosing education. So this is the idea behind studying probability. We should be able to come up with the numbers. Alright, so the primary reason why we are studying probability is to be able to make better decisions. As we talked earlier, what are the chances of event A happening, event B happening, event C happening, and then what is the impact of those? Should we come up with product A, product B, or product C? Should we open a new line of business in city A, city B, or city C? So this is how we are going to use probability to make better decisions. Let us see some basics of probability. When people say probability, odds, or chances, all these three words, they mean the same. So for example, they may say, what is the probability of India winning the football match, or what are the odds of India winning the football match, what are the chances. So all these three words mean the same thing, right? Earlier we talked about how we are planning and how we are planning and making decisions based on probability. We talked about how people are choosing education over sports. Even in the insurance industry, if you see, the vehicle insurance for young people is higher when compared to middle-aged people. How did they come up with that? And the health insurance for young people is less when compared to middle-aged people. For middle-aged people, the health insurance is more, whereas for vehicle insurance for young people it is more, and for middle-aged people it is less. Why is that? Because the chances that middle-aged people drive rashly versus what are the chances that a young people drive rashly. And whereas health, what are the chances that young people fall ill versus what are the chances that a middle-aged person may fall ill. Here the chances of the middle-aged person falling ill is more, so that's the reason why the health insurance is more. Whereas for young people, the chances that they fall sick is less, so the insurance is less. Whereas here for rash driving, it's probable that young people are more risky and they take more risks while driving, which they should not. So that's the reason why the vehicle insurance is more. And for middle-aged people, they don't drive rashly or they don't take as many risks as the young people, so the vehicle insurance is less. So here we see that how the insurance companies are using probability to calculate the insurances. Now there are different decision making models. Remember, as an MBA or a statistician or as a smart person, we should make decisions based on logic, based on rational thought, and along those lines we have two different models. One is a deterministic model and another one is the probabilistic model. In deterministic model, we know determine, meaning the possible outcomes are all known upfront, so we can determine. So because we can determine, we use frequency distribution to make the decisions in this kind of situations. And in those situations where either the events or the outcomes are not known, we use probabilistic models and probability distribution to make decisions. The probability of any event, either there are two possibilities, two extreme possibilities. Either the event never happens or certainly happens. For events that never happen, the probability is 0, and for events that certainly happen, the probability is 1. And this is the minimum value in probability and this is the maximum value, and all other probabilities fall between these two values. So let us take a fair coin and toss it. What are the possible outcomes? Either we get a head or we get a tail. There are only two possibilities. So if somebody asks what is the probability of getting a head, we say it is 1 out of 2 possibilities. So 1 out of 2 possible outcomes. So the probability of getting a heads or a tails is 1/2. Now probabilities are expressed as fractions like 1/2 or decimals, we can say 0.5. Similarly, a couple is having a child, so the chances of getting a boy, or the two possible outcomes are getting a boy or a girl. So the probability is again getting a girl is half, getting a boy is 1/2 is 0.5. Okay, sample space. So there is something called a sample space, a term in probability. This is a term in probability. What this means is the set of all possible outcomes of a probability experiment. Let us say we have tossed a fair coin. What are all the possible outcomes? All the possible outcomes are heads and tails. So this is a branch of mathematics called sets, in which all the possible elements are enclosed in flower brackets and separated by commas. So this is a set and it contains all the possible outcomes. This is called a sample space. Similarly, let us say that we have tossed two coins. What are all the possibilities? We can get both heads, we can get one head and one tail, or we can get one tail and one head, or both tails. So there are only four possibilities, and all these four enclosed in a bracket. This is the sample space of a two coin toss experiment. Now in real life, we like to calculate the chances of getting into a particular college or chance of getting a particular job in a particular company. This is how in real life we are using probabilities. Some more terms in probability are mutually exclusive. What does mutually exclusive means? Mutually exclusive means if one event happens, it will stop the other event from happening. This is mutually exclusive. So let us say in a coin toss experiment, again you will get either a heads or a tails. So if we get head, we will not get a tail, and similarly if we get a tail, then we do not get a head. So these events are mutually exclusive. Getting a heads excludes or removes the tails, or getting a tails removes the head. This is called mutually exclusive. Odds in favor of happening. This is same as saying what are the chances of something happening. Odds against the happening means what are the chances of something not happening. So let us say the chance that you pass in an exam is 90%, or 90 by 100, or 0.9. So the chance of the odds in favor of you passing the exam is 0.9, and because we said the maximum probability is 1, the odds of this not happening is 1 minus 0.9, or 0.1, or only 10%. The chance that you will fail this exam is very low, and it is 0.1%. So if there are two mutually exclusive events, and we know the probability of something happening, we can calculate the probability of not happening by subtracting from 1. So in a fair coin toss experiment, what is the probability of getting a heads? Half. So what is the probability of getting a tails? It is 1 minus 1 by 2, or 1 by 2.